Hello everyone and welcome to my review of the 2024 AMC12B. The AMC12B is going to have some overlap with the AMC10B in terms of questions. So if you have seen the review for the AMC10B, of course there'll be some questions here that you can skip over. But my target is the same. I hope to go through the questions in a total of not too far from 75 minutes. In terms of the not too far from 75 minutes, one more reminder to everyone, you do not need to aim for exactly finishing or even trying all the questions in 75 minutes unless you are attempting to, let's say, get a DHR. Because, for instance, in this AMC 12, the AIME qualification mark was 88.5, the distinction mark was 118.5, and the DHR was 139.5. Now these are very far apart because based on the AMC 12, and I'm sure that you're familiar with the scoring, this is including blanks, somewhere around 12 to 13 questions versus somewhere about 18 questions, and then this is somewhere about 23 questions. So you are quite easily going to say that I could take my time if I'm aiming only for AIME qualification, because if I just need to do 12 to 13 questions, I have a lot of time for each problem, especially because I don't even need to try the hard ones. Whereas if you're aiming for a DHR, then you know you need to go roughly at the pace of this video, where I'm trying to finish it in 75 minutes, as you can see again from the time that this video ends. So we're going to try to run through it, and I will not be going through the calculations too carefully, in the sense that if I were a student, I'm not going to worry about writing things out in super complete sentences. And neither should you if you are doing this at a DHR rate. But if you are taking, let's say, for the first time, or you're hoping to qualify for the AIME for the first time, feel free to slow down and pause the video and just think about some of the steps that I'm moving quickly through. And you will see that, oh, yeah, everything that I'm writing down shouldn't be too crazy, with the exception of maybe one or two more tricky formulas towards the back. Okay, so without any further ado, let's begin. Question one, in a long line of people arranged from left to right, you have got 1013 people, meaning that there are 1013 here, this is the guy, and there are 1010 people here, where this is the guy. So 1013 plus 1010 minus 1 is 2022. Question 2. What is 10 factorial minus 7 factorial times 6 factorial? If you know your factorials, you can always just do multiplication and write them out. But I see that the options are quite small, so I suspect something nice happens. To check that, I'm going to factorize out 7 factorial. 10 factorial is 1 to 7 with 8, 9, 10. As it turns out, both of these are 720, so answer is 0. Question 3. For how many integer values of x? So integer values of x means I just need to estimate 7 pi. Now I know that 7 pi is around 22 because pi is around 22 over 7 is a well-known estimate. Now it turns out in this case that we don't actually need to know whether it's slightly more or less, because if it were the case that it is 22 point something, your x can be negative 11 to positive 11, would give you 23 values. But that's not an option. So I can infer that, oh, 7 pi is actually going to be 21 point something. In which case x goes from minus 10 to 10, and there are 21 values of x, so option E. If you had used the estimate of pi is about 3.1415, then you will know that 7 pi is actually 22.99. So it's, sorry, 21.99. It's very close, but that's why they are nice enough that they didn't try to trick you with having another option that says 23. Okay, question 4. Balls numbered 1, 2, 3, and so on are deposited into 5 bins. Ball 1 in bin A, 2 and 3 in bin B, the next 3 in C, and so on. So it's going to just cycle around A, B, C, D, E. There is 1 ball, then 2, 3, 4, 5, 6, and so on, in terms of number of balls. I just need to know at which step 2024 is reached. So the sum up to what is going to be around 2024. Right? This is what I want to know. Now I know that the sum from 1 to n is n plus 1 over 2. Therefore, I want this to be around 2024, means I want n times n plus 1 to be slightly more than 4,000, meaning that since 60 squared is 3600, n should be a bit more than 60. For convenience, I'm just going to start from 60, because that's easy to calculate, right? 60 times 61 over 2 is 1830, and then I just keep on adding until I go past 2024. This definitely goes past, meaning that it is on the 64th step that this ball 2024 is deposited, and the 64th step, clearly this is a cycle of 5, so it will be remainder 4 and thus bin D. Question 5. You have got this rectangle here. Wx is 4, Wz is 8, M is on xy, A is on yz. This is a right angle. So there's no information in the question except for the equal areas of this and that. That already tells me that my area is, I can just call this x, and this will be 2x, so that the areas will be the same, right? The ratio of the bases is 2:1, so the other side must be 1:2. Alright, so that means that I can write down, this is 4 minus x, this is 8 minus 2x, and then before I can find the area of WMA, I probably need to know what is x, right? And that information that we have not used is the right angle. You can use Pythagoras in order to handle this, but a simpler way is just to note this configuration. When you have a right angle on a straight line in this figure, you have just got two similar triangles, and this is 2 times of this, therefore this is 2 times of this, and therefore x is just 1. This is 2, 6, 3, 1, and then to get the area in the middle, I don't need Pythagoras, I can just take the rectangle minus the outer stuff. So 32 minus 17 is equal to 50. That is option C. Okay. Question 6. Melanie changed some plus signs to minus signs in this thing such that it became negative. What is the least number of plus signs that could have been changed? Firstly, I must know what is the current total. And the sum of odd numbers, if you notice the pattern, is 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. Square numbers. The sum of, therefore, 50 odd numbers, I can quickly know that it is 50 squared, or 2500. If I want to change a few plus signs, I know that I want to just change the ones behind to minus, and therefore you're going to end up with a bunch of things that are added and then a bunch of things that are subtracted. And this is supposed to be negative. And therefore, I can use the front half, because the front half is also a square number. This must be less than half of 2500. And I can look for the nearby square numbers. As it turns out, 35 squared is 1225 and 36 squared is 1296 are the near ones. And therefore, you can at most have 35 numbers here and 15 numbers here if you would like to have it be negative. With 36 numbers, it will definitely be positive. So therefore, 15 is our answer. That's option B. Question 7. The national debt of the US is on track to reach this. How many digits does this have when written as a numeral in base 5? Okay, numeral in base 5. If let's say that you have got 1 followed by, let's say, n zeros in base 5, base 5 just means your place values are powers of 5. So this is actually just 5 to the power of n. In other words, if I ask you how many digits it has, I just need to estimate this as what is 5 to the power of something that will squeeze this thing so that I will know the closest power of 5 and therefore know the number of digits. To know the closest power of 5, I basically can take log base 5. Log 5 is 1, and then log 510 is the reciprocal of log 10 5. And since they tell you that this is sufficient, this is going to be about 18 point something. So 19 point something. Meaning that it is between 5 to the 19 and 5 to the 20. And so 5 to the 19 would be 1 followed by 19 zeros. 20 digit number in base 5, meaning that my answer is 20. And this is how you would actually estimate the number of digits of something, not just in base 5, but even in normal circumstances. Taking log base 10 would give you the number of digits because it's estimating what power of 10 is slightly smaller than it. Okay. Question 8. A dartboard is this region B in the coordinate plane. The target is this region. Both of these are graphs that are not the most common, but also not very complicated because your x and y, the plus and minus don't affect anything. So therefore, if you throw away the absolute value and you know how that looks like, x plus y is less than or equal to 8 would be this line. And so therefore, just reflect it in 4 directions. That's B. My target, x squared plus y squared minus 25 squared less than or equals to 49, means that this is between minus 7 and 7. This means that it's between 18 and 32. And so therefore, it's 2 circles. Square root 18 sized. And square root 32 sized. And the target is the part in between. That's pretty easy to find. So a probability is just going to be this area over the entire area because it's a random point. But this area is very easy to find. It's just going to be 14 pi. This area is easy to find because this is just a square, or you can call it a diamond. It will be two 8 by 8 squares if you pair them up. And so your fraction, 14 pi over 128 is 7 pi over 64. And 7 plus 64 is 71. At this juncture, I would like to remark on how many B's there are, right? If you realize how many of them have been B already, quite a lot, right? 5 out of 8 of them have been B. In the AMC, especially from last year onwards, due to some anti-cheating measures, your answer options may be scrambled, or even the question order may be scrambled, whether you're doing it on paper or online, as well as different time zones. What that means is that, number one, you can find this paper in the description below in case your questions are in a different order. But number two, it also just means that please do not get surprised if, let's say, the same option appears a lot, right? Don't try to use that kind of guessing mechanics, because if they scramble the options, then there's no good reason why yours cannot just have B, 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 or something like that. Right, question 9. By the way, all of these questions so far, except for number 7, all of these have actually been in the AMC 10 as well. So they are just sort of a bit earlier in the paper than the AMC 10 usually would have them. But none of these are supposed to be harder than AMC 10 questions. It's just that they come a bit earlier. Okay, question 9. This is a really annoying one. And we need to be quite careful. And in fact, I would probably skip this question if I weren't just doing this as a review in order. The only reason why I'm not skipping it immediately is because I don't want to confuse you, but this is going to take quite a bit of time to do correctly, because they just tell you things like positive integers instead of telling you what it is. So there's a lot of room for things to move around. First of all, range. Range means the biggest to smallest. The range is 7, means that my cases are that it goes from 0 to 7, meaning that x went in front and is 0. It's 1 to 8, meaning that z went behind and is 8. Or it is x to z, and z minus x is 7. 3 cases. That's range. The mean, well, I can just add up all of these together. The current sum, if you did a quick addition, is 24.8, and then x, y, and z. This is supposed to be a multiple of 9. For this to be a multiple of 9, that would imply that your x plus y plus z, let's write it down here first. It can't be negative, but it can be, let's say, 2.2. That feels unlikely. 11.2, 20.2, and I don't think that's and so on, right? Because all of them are going to still be between 0 and 8. They cannot just run off. Right? Because this one is saying that x is less than 1, z is more than 7, but it's still going to be between 0 and 8. So I don't see any of the other values being significant for me. Okay, for median, it's either x, y, or z that is the median, depending on where everything goes. Because it can't be any of these, and it can't be 1 or 7. That can never be the middle number. Okay, now let's see all the 3 cases. I'll call the cases A, B, and C. Case A. this is x, and then there are two numbers to put in, which are y and z. If I want y to be the median, then z has to be somewhere in here. If I want z to be the median, then z would actually not be the median here. Z would be down here, and then y would be down here. Okay, so let's check this case. How does that work? Remember that the median is a positive integer. So if y equals to 4, okay, looking at my target here, x is 0, z, that doesn't work, right? It cannot be negative, it cannot be 7.2 because that goes out of range. If y equals to 5, then z can be 6.2. It's okay if it repeats. And then for this one, if z equals to 3, oh yeah, that doesn't work again because there's nothing that it can reach with y being between 0 and 3. Okay, so that's case 1. Now you understand why this is pretty annoying. I say again, I would skip this question, and the only reason why I sound vaguely coherent is because I was incoherent when I was talking about it in the AMC10B video. And now that I know how messy it can be, I am trying to organize my thoughts a bit more, but this is still a lot of work. Okay, the next one, 1 to 8. Same logic as before. I can put x and then y is here. Or I put y and then x is here. Sorry, again, wrong. I can put y down here and then x is before that. So we try again. If x equals to 6, and then I have already set z to be 8, I can make y to be 6.2. If I were to put it here, I have got y equals to 4. That would require that if x must be satisfying one of these, x plus y plus z, y and z already add up to 12. That's not going to happen. And if I did y equals to 5 and it is 13, that is still not going to happen. So both of these will fail. Case number 3, if I put x and then I have got 1, 2.2, 3.2. I know then y must go in the middle. That must be the median. Then if y equals to 4, and I know z minus x is 7, I want to target, well, if this is 4 and z minus x is 7, z plus x is slightly more than 7, if I target 11.2, this can work with z being 7.1 and x being 0.1. So case number 3, that works. If y equals to 5, then that will drop down to 6.2. That doesn't work because then your x will be negative, which the question doesn't forbid, but it just means that the range is going to be bigger than 7 if your x is negative. Therefore, my answer is that there are 3 cases, and also this is a massive time sink, and therefore we need to rush if we are going for a DHR rate. Right? So we've taken about 20 minutes so far for 9 questions, of which a big chunk is this one. If you are aiming for AIME qualification, all the way to 9 questions, if you took like 50 minutes, you are still fine, right? But if you're aiming for more, then we need to speed up. So let's try to gain back some time on these few questions. Okay, question 10. Now, what value of x satisfies this? The thing about logarithms is that they tend to be nice to combine, but not in this way. I will reciprocal it first. Because the sum and product of logarithms are not nice if they have different bases. So I'm going to now then split it open as a fraction. This over this is 1 over log 3x. This over this is 1 over log 2x. And then when you reciprocal a log, it flips the order back again. So log x 6 equals to half. X to the 1/2 is 6, meaning that x is 6 squared, which is 36. I mentioned earlier about the problem order being scrambled. You can see that question 9 took us about 7 times longer than this one. Question 11. As you can see, these look like equations of circles. They look like equations of circles, but you do not really need to think of them as equations of circles because h plus k, just add them up. And then just complete the square for both. X and Y can be anything, right? Because H and K are for you to choose. So in a sense, I just add them up and then just look at this and say that, okay, the minimum value is negative 34 when X is 4, Y is 1. There's nothing stopping you from any choice of X and Y. So again, very fast. We are making back time from what we burned on question 9. Question 12, what is the mean? So the average. When it says mean, the default is arithmetic mean. There was arithmetic mean in the other paper. This is just the average. This is a classic question. It's a classic question for the sum of sine squared like this because your sine squared 89 degrees is going to be cosine squared 1 degree, and that means that sine squared 1 plus sine squared 89 is now sine squared plus cosine squared equals to 1. And likewise, therefore, we can sort of generalize this to sine squared of n degrees plus sine squared of 90 minus n degrees is equal to 1. Therefore, you will end up with, there are 44 pairs, 189, 288, 44 pairs. You have got sine squared 45 degrees is half. And then you have got sine squared 90 degrees, which is 1. This one you divide by 90. So 45 and a half divided by 90 is 91 over 180. If you made it to this point and done 12 questions, then congratulations, you probably have enough for the AIME. If you didn't make any careless mistakes, we have got that here in about 25 minutes. That's why I said you can take actually 3 times longer if you are doing it for AIME qualification. Okay, now let's press on. Question 13. This is a complex number question. Z is a complex number with positive imaginary part, real part greater than 1 with a modulus of Z equals to 2. In the complex plane, so I'm going to draw the complex plane. positive imaginary part and a real part greater than 1. If let's say that I draw this as just to remind ourselves the modulus is 2, real part greater than 1 just means that your choice is somewhere in here. If this were 1, then this is 60 degrees or pi over 3, which means that when you take this, the argument times 3 is still less than 180, so everything is going to be above the real axis. Now, since everything is going to be above the real axis, I don't really need to worry about anything too complicated. I can just say that my points, there is a 0, there is something here, and then if let's say this is theta, the next one here, the next one let's say is here, I can just split up the area into two triangles where the length of z is 2, meaning that this is 4 and this is 8. Therefore, I can use my area half AB sine C formula to say that the area is half times 2 times 4 sine theta, half times 4 times 8 sine theta. So therefore sine theta, this is 15. Calculate it and it is equal to 3/4. And so the imaginary part of z is just 2 sine theta, which is equal to 3 over 2. If you are doing the AMC12 and you have not learned some topics, right? Let's say you have not learned complex numbers, just skip them because you're not going to be able to discover a property of complex numbers that you have not heard of in like 3 minutes, right? So just skip it. Most likely, if you say you have not seen complex numbers before, that means that you're taking the AMC12 maybe for the first time, or the second time you are most likely not expecting to try to get a perfect score, right? So feel free to just skip those. Okay, question 14. You have got this thing in the coordinate plane. This is 0, this is 1, this is 2, this is 3, these are 2 random logs. Okay, so area, I will just use my shoelace formula. The shoelace formula for area of any polygon is something that is normally I would actually need to check whether it is orientation is clockwise or anti-clockwise. The area may turn out negative, but never mind. If it turns out negative, then I know that I just put it in the wrong order, right? So 0 times 2 log 2 3 times 3 log 2 7 times 1 minus the other way. This is the shoelace formula. The zeros disappear, and so you are basically going to end up with 2 log 2 3 minus log 2 7, which simplifies to log 2 3 over root 7, which is yet another option B. if you did not know the shoelace formula, you can draw it out and basically take the area of a rectangle minus the area of some outer triangles, kind of like what we did earlier on for this question, right? You can just draw it and the same thing happens exactly. But for us, if let's say we are in a hurry, of course, having a formula is good to know. So you can just do a quick search if you're not familiar with the shoelace formula, how it will look like if I am going beyond a triangle to, let's say, a quadrilateral. How will it then appear, right? You can go and check that out. Okay, question 15. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. Okay, this is obviously possible to do in a lot of ways. When it says indistinguishable 4-person committees, meaning that the order of your committees does not matter. There are 2 ways to do this sort of indistinguishable questions. One is that you divide at the end. The other is that you first do something to distinguish them. And since there are these chairpersons, I'm going to do that. I will just say that let's pick 4 chairpersons. I will put the chairperson at the 4 committees, and now each committee is identified as the committee who has this chairperson number 1, the committee with chairperson number 2. So now they are distinguishable for the rest of what I am doing. So I've decided on the chair. The next thing I need to decide on is who goes where. So pick 3 to go into committee 1, then 3 to the next, 3 to the next. 3 choose 3 if you feel like writing it, that's 1. And then I actually have also to pick the secretary from the other 3 people for all 4 committees. So the secretaries have to be picked. That's the number of ways, and the question is asking me to find how many trees are there in the factorization. I can see 4 down here, so 3 choose 3 is 1, I just check the rest. Okay, this one, the only multiple of 3 gets cancelled out, so nothing there. This one, you get cancelled out. Okay, this one, there's a 3 that survives. This one doesn't have, so there's only 1 extra 3 to go with 3 to the 4, and so it's 3 to the 5. Okay, checkpoint again, 15 questions. We have taken about 35 minutes. This is about as much time as you can spare for the first 15 questions if you are aiming for doing all the questions. Right? So you give yourself 40 minutes or 4 minutes per question for the last 10. That's about as far as you can afford. If you're aiming for a distinction, you could take all the way until over an hour for 15 questions. Most likely you are either there or almost there if you are, that is your target. Okay, how many different remainders can result when the 100th power of an integer is divided by 125? Euler's theorem is the only way that you can handle mod 125 for a 100th power of any number, because it tells us that a to the phi n is congruent to 1 mod n. Once again, if you're not familiar with Euler's theorem, search it out. The condition that you must remember for those of you who do know Euler's theorem is that GCD an is 1. Don't forget about that. Otherwise, if let's say a is a multiple of n, obviously any power is still 0. So, conveniently enough, phi of 125 is 100, which means that a to the 100 is congruent to 1 mod 125 if a is co-prime to n, which is if a is not divisible by 5. Since 125 is 5 cubed, that's the only common factor we need to avoid. So if 5 doesn't divide a, then 1 mod 125. If 5 divides a, then 0. So that's it. 2 possibilities. Okay. 17. Equilateral triangle ABC with side length 14 rotated about its center. Okay, so they have a common center. I'll call that O. And then I'm now given that this area is 91 square root 3, and I want to know what is theta. Theta is the angle of rotation, which basically means that it would be one of the many copies of this angle down here. Okay, so I can probably do this without too much trouble by doing some trigo. As long as I remember that literally this is a concyclic hexagon because the center is mentioned. So therefore, when I want to do trigo is that this triangle equilateral, I can find the area. I can't count, sorry. Half times 14 squared times sine 60 degrees is 49 root 3, which means that each of the remaining portions of the figure, these three outer triangles are 14 root 3. Now, I mentioned about the fact that we can do a little bit of trigo. I mean, there is tangent theta, so I know I definitely will also need to use a bit of trigo, but it is probably useful to note that this is also 120 degrees. It is just 180 minus that 60-degree angle by my cyclic quad. So now I need to sort of decide what is the best way to get to tangent theta. To get tangent theta, however, I can use sine or cosine pretty freely. Now, by symmetry, you will see that this figure, it certainly looks, and you can verify that, let's say, this would be isosceles, meaning that this angle is half theta and this angle is 60 degrees minus half theta. So if I call these ones x and y, and I know that this is 14, I can use my sine rule in order to get what each of them are. Okay, and then likewise, y will look like this. Actually, I don't need y at this point, right? I can just say that my area 14 root 3 is half times x times 14 times sine of this angle. X is this. And so I have got sine half theta sine of 60 degrees minus half theta is equal to 3 over 14. From here, I am going to use my product to sum. I will put a factor of 2. And then I'll say that cosine of the difference minus cosine of the sum is that. So cosine 60 minus theta is 3 over 7 plus half, which is 13 over 14. Finally, I can use this to get to tangent using my identities. So sine is square root 1 minus cosine squared. And then tangent is sine over cosine. And I want to get to tangent theta, so tangent of 60 degrees minus this. Okay, so tangent 60 minus tangent of this over 1 plus this times this. Is there a better way to do this? Possibly. You end up with okay, so 5 root 3 over 11. But I don't think it's going to be like possible to completely avoid doing some semblance of an identity at some point in time. Okay, well, so that took a little bit of time. Let us continue on. Question 18. A and B are randomly chosen without replacement from the set of integers with absolute value not exceeding 10. So minus 10 to 10 for both. What is the probability that this has 3 distinct integer roots? Okay, first thing you notice is that without replacement means that there are here, sorry, what am I writing? Minus 20, 20. Minus 10 to 10, there are 21 times 20, which is 420 choices. I just need to find how many of them have 3 distinct roots, and then the answer is that over 420. Which already means that this are wrong. It's either 4 over 420 or 5 over 420. For probability, always keep an eye for this kind of tricks. If you have got 30 seconds left, at least you can try to guess. If you have got a proper amount of time left, now we can try to solve it. To try to solve it just means count, are there 4 or 5? I know that my roots by Vietas, if I let the roots be PQR, I know that PQR is negative 6 and they're supposed to be distinct integers. So all I need to do is to check each of these combinations of 1, 2, 3 in different ways. It's also possible to be 1, 1, 6 if I make the ones have plus and minus, and that is all. Oh, that's not all, right? I can have all negative as well. Okay, now that is all. In all of these cases, the A is definitely going to be fine. Negative of the sum. And then we may just have to do a quick calculation for B. The good news is that for B, clearly it is going to be that each of these, there will be odd, even, even. So it's never going to overlap. So the only one that I need to concern myself with is, does it exceed the bound of 10? Unfortunately for me, this one is 11, so it fails. But the moment that one fails, I know that the rest must work because the smallest option is 4 over 420. So you can check that the rest of them give you a valid B, but I can straight away say answer is option C. Question 19. This was also from the AMC10, and the same recommendation, always find a pattern. How do you find a pattern? Well, in this case, the Fibonacci numbers is part of the pattern, but also each of these look like they are in the form f2n over fn. So let's write down the Fibonacci sequence at least for the smaller ones. You have 2 over 1, and then you have got, sorry, not 2 over 1, you start with 1 over 1. F2 over F1 is 1 over 1. Then after that, you have 3 over 1. Then you have 8 over 2. Then after that, you have 21 over 3. And then you have 55 over 5. And you will recognize that 1, 3, 4, 7, 11 kind of does its own Fibonacci sequence as well. It's the same recurrence as the original one that starts with 1, 1. This one starts with 1, 3. Why does that happen? I don't know. It's the AMC12. I don't have time to find out. You can go and prove it by induction, but I will just either test one more to check. 144 divided by 8 is 18. Yeah, okay, I'm quite sure that's enough. So just continue adding 29, 47, 76, 1, 2, 3, and then just add all of these up. Since there's only 10 of them, I don't need to find a pattern for addition, right? I can just do normal addition. The sum is 390. Please don't try to prove anything in the AMC. You don't have that much time. Another thing to say is that please do not also assume that the questions are strictly in order of difficulty, because this is actually a lot easier than the other trigo question in front. They tell you here that your triangles, there are two small familiar triangles and one other one where the angles sum up to 90 degrees. The smallest angle here, the tangent is 3/4. This is 5 over 12. And so if I want the third unknown angle, it's just 90 minus those two, because that's what the question told me. So let's just find what that is, and I'll immediately know what that triangle is. Simple as that. Tangent of 90 degrees minus this is actually just cotangent of A plus B, or just the reciprocal of the usual identity. Okay, so just a quick calculation. This will be 11 over 16. This one will be 7 over 6. So 33 over 56 is the ratio, meaning that this is 33, this is 56. Quick Pythagoras, that this is 65, and therefore perimeter is 154. By the way, primitive just means no common factors greater than 1 in the side lengths. So obviously I could have scaled this up beyond 33, 56, 65 to, let's say, times 10. So primitive just ensures that it has no common factor, and thus the answer is uniquely determined. That's all. Okay. 21. This is quite a well-known configuration that an angle is twice of the other one. And in fact, it was in our SMO Junior Round 2 from the year I took it in 2009. So what is the statement? The statement is that if angle B is 2 times of angle A, then I can chop it up like this. If I can chop it up like this, then what will happen is that it says integer side lengths. I will be able to say that by drawing this angle bisector, triangle ABC is similar to triangle BDC. And therefore, it will confirm to me that CD over CB is equal to CB over CA. So CD is equal to A squared over B. On the other hand, the angle bisector theorem tells me that CD is actually going to be A over A plus C of the side. And so that becomes the condition that is ambient here. B squared equals to A times A plus C. It's easy to see that this is also a sufficient condition, meaning that if this were true, then everything we drew here will fall into place. So the angles will be twice as much, because if the angle bisector makes these two similar, we have what we want. Now all you need to do is just to try to substitute in values until you can make it all work, since this is the least possible parameter. If you try, let's say B equals to 2, your A equals to 1, C equals to 3. That's not going to satisfy the triangle inequality. B equals to 3, you get A is 1, C is 8. That also fails. If you have B equals to 4, it can be 1 and 16 minus 1. It can be 2 and 8 minus 2. That still doesn't work. And if you have B equals to 5, so I'm just listing until it works, right? There's this is not going to work. If I have B equals to 6 though, then I will finally find that, oh, the one that works is if A is 4, A plus C is 9. So 4 and 5. So perimeter is 15. As you can see, we are now coming up to like 55 minutes from the moment that we started. So this is really like the pace that we need to maintain. So as you are doing the AMC, please get used to also thinking continuously for 1 hour 15 minutes. That's one of the challenges we have, because very rarely do we need to continuously focus on something as carefully and as intensely as in something like the AMC. Regardless of how many questions you're doing, I'm sure you're focusing intensely. So try to get used to that. Okay, question 22. This is surprisingly not that hard, it's just a bit tedious. You've got A, B is 40, AC is 42. Yeah, of course, a lot of ways that this can be drawn, right? So X is this length, and define a function f by letting fx be the area of ABC, the domain of f is an open interval PQ, and the maximum value R of fx occurs at x equals to s. Okay, so there's a lot of things going on here, but it's not actually that hard. Let's do it one at a time. The first thing is that the maximum area clearly happens when this is a right angle. Right? Because your area is half AB sine C, the maximum area happens when it's 90 degrees. This is a 20, 21, 29 Pythagorean triple. So two things. The first is that this is 840. The second is that then we know that in our right angled triangle by Thales, these three are all equal, so that is 29. So that's the maximum value portion, completely unrelated to the domain portion. So the domain portion is saying that what is the smallest and largest possible values of f. Now, when you are looking at the area, the domain of f, meaning that it's just actually asking what can be the length of x. It has nothing to do with the area anymore because x is the length of the midpoint. So if I want to know what is the range of x, very easy. We just use our Apollonius theorem. So Apollonius theorem, this is for the length of the median, is going to tell us that this is not for a right angled triangle, mind you, but a sanity check would also confirm that. So 40 squared plus 42 squared is going to be equal normally to half x squared plus hang on, let me try to remember Apollonius theorem. So actually how I remember Apollonius theorem is that for a parallelogram, the sum of the squares of the sides is equal to the sum of the squares of the diagonals. That's normally what actually I do. So like 2 times this squared plus this squared equals to this squared plus this squared. So that's normally how I remember Apollonius theorem. Perhaps maybe that's just okay to write it in that form. And so since I am writing it in that form, and I know that by my triangle inequality, my A is going to be between 1 and 82. Then that would also imply that I can substitute in here and solve for x. You will find that x is going to be between 1 and 41, which incidentally is actually the extreme cases of your triangle inequality if your A and B are on the same side in a straight line or on opposite sides for a straight line. So that's actually not too surprising. Okay, so now we've got everything. I just add them all up and the answer is appropriately 911. Pretty scary question when you read the amount of things going on, but it's just a few small things. It is not as hard as a typical question 22. Okay. 23. Right pyramid has regular octagon A, B, C, D, E, F, G, H with side length 1 as its base and apex V. Segments A, V, and DV are perpendicular. Okay. The question is, what do I actually want to draw? I'll draw a circle. When you have got a regular octagon, actually just draw quarters and then eighths. That will be a regular octagon, and I will just source it out. So up there somewhere is V, where this is supposed to be perpendicular. Okay. Now I do know that these are supposed to be equal. When it says right pyramid means that the apex goes up from the center, right? That's what right pyramid means. So therefore, I actually can just say that this is going to be 90, 45, 45. So with this over root 2, now I need to also decide on how I'm going to find the height. But the height, I can just use Pythagoras because this is going to be that. So if I call this O, my h squared equals to AV squared minus OA squared equals to half AD squared minus OA squared, and therefore this has now been downgraded to a 2D geom question. That's how we want to handle this most of the time. It's been downgraded to a 2D geom question, half AD squared minus OA squared, and so let's just use the bit of trigo that we might have to find what this is. This is a regular octagon. It's a regular octagon. So this angle here is 135 degrees. So if I were to use my cosine rule, and I just call this radius r, incidentally, this is actually quite nice because it tells me that AD squared minus 2r squared equals to square root 2r squared, and therefore this is half of that, which is r squared over square root 2. If I want to get r squared over square root 2, I would need the area, sorry, not the area, I would need to use the side length 1. So I will just use that cosine rule again. To r squared 1 minus cosine 45 degrees this time. Okay, so we just end up with this over root 2. You rationalize and you sort it out, and it would not be too surprising that it turns out to be 1 plus root 2 over 2. Right, by the way, the question asked for the square of the height, right? So that's why I never needed to square root this, otherwise you just get a pretty ugly nested set. I'm showing one way, which is literally different from the way that I would have done it last year, which is also different from the thing that I have written down in front of me, which is different from the official solution. When you've got a regular polygon, you can basically do anything you want. So this is just that since I see a lot of nice squares, I use the cosine rule throughout, and Pythagoras, so that I never have to square root any length. Okay, 24. Another geom. So as mentioned in the thumbnail, there is so much geometry here. But this is not very bad if you know what to do with integer in radius as well as lengths of altitudes. Both of those are related to area. But unfortunately, my ABC have been used up here as lengths. I am going to just let the area be equal to, let's use capital K, often used. And so that means that my sides, half times base times height is K. So my sides are 2K over A, 2K over B, 2K over C. That means that my area is equal to RS, the semi-perimeter. This will be the semi-perimeter, which cancels off to imply that R times this equals to 1. Okay, everything here, remember, R, A, B, and C are all integers, and A, B, C are up to 9. Meaning that this is going to be at most, or rather, at least 1/3. And if it is at least 1/3, then it is going to imply that R is at most 3. Okay, so at this point, I just have 3 cases. R equals to 3, I already know what that will entail. Before I start going through the other two though, do realize that your 1 over A, 1 over B, and 1 over C are proportional to the side length, so that also must satisfy the triangle inequality. So that means that any one of these cannot occupy more than half of my total. So when I have got 1 over A plus 1 over B plus 1 over C is half here, none of them can be 1/4 or more. If none of them can be 1/4 or more, that is pretty restrictive. Same thing with this. None of them can be 1/6 or more. Wait, sorry, no, this is not 1/3, this is 1. So none of them can be half or more. Yes. So that's good because if let's say all of them are less than 1/2, this one actually just gives you A equals to B equals to C equals to 3. And if they're all less than 1/4, and you know that 1/6 plus 1/6 plus 1/6 is half, I don't have that many options. You can check that there will actually be one more, since if I want to use, I can just check what does it look like if one of them is 1/5. If one of them is 1/5, by listing you will find that okay, 5, 5, 10 also works. And that's it. So 4 options. Okay. Last one. If I were trying to finish this paper, I'll be pretty fed up because my goodness, you now throw this thing at the end where the question alone takes me 3 minutes to read. So let's quickly speed through it. There are 6 balls, striped or dotted red or blue. and you're doing all at random, you place them in an urn, then after that Frida picks this, and then these events may or may not be independent. Okay. Well, what the two events are is about the red and the striped, and I'm asking for the probability that they are actually independent. All right, now let's sort of organize my info. There is red and blue, there is striped and dotted. In order that they are independent, if I were to just call this W, X, Y, Z, in order that they are independent, it basically just means that, so there are these 6 balls. Kind of want to say this, meaning that your choice of whether it's red or not doesn't affect the chance that it's striped, except that because of the fact that some of them can be 0, I don't want to write fractions. I will instead just say that this is true. Right? Because if the probability that one thing never happens, I mean, is that one thing never happens, so therefore the probability is 0, then by this definition of independence, if let's say A never happens, then that's okay, because if A never happens, both sides become 0. So I just basically have WZ equals to XY, and these must add up to 6. Okay, so now that I have this, I basically just have a huge bunch of casework to do. The huge bunch of casework to do of how do these two multiply to the same thing, but the good thing is that they add up to 6. So it's not like as if there are a huge amount of cases where this can happen. So let's just quickly see. If they were to both multiply to 0, that is possible. So one case is that your WZ and XY are both 0. Now, if WZ equals to XY equals to 0, I'll deal with that later. I just want to see, are there other situations? And if you go through a quick check, you realize that the only other situation is just 1 times 2 equals to 1 times 2. So WZ equals to XY equals to 2. There are basically no other ways that you can distribute your numbers. Okay, so let's handle them separately. The first case is basically going to be that one row of this is 0. Now, the probability that one row of this is 0, let's say, is just 6 of the coin flips all landed on dotted, for instance. That's half to the power of 6. There are also the columns, and there are 2 rows, 2 columns, so 4 ways in which you could end up with a row or a column being fully 0. However, I need to subtract off the case where 3 of them are 0 because those have been counted twice. That is the case where all 6 of them ended up in the same spot. So minus 1 half to the power of 12 times 4. WZ equals to XY equals to 2. That is a case where I have got just 1, 1, 2, 2 in some order. Let's say this can swap, this can swap. So there are 4 choices. And I realized that I don't need to think of it as 12 separate flips this time. I can just think of it as that 1122, there are 6 factorial over 2 factorial, 2 factorial different orderings of what happens to the balls. And then if I fix the order, then that is just another 1/2 to the power of 12 again. Okay, so what is left is just for us to do the calculation. And if you were to calculate this case here, when they are equal to 0, it's going to be 63 over 1024. This one is going to be 180 over 1024, and so the sum is 243 over 1024. So that took us slightly over an hour, 15 minutes. And I'm already going at essentially as fast a speed as I can write and talk. As you have also noted at the start, the DHR is 139.5, which is 23 questions at least, which basically means you must have tried everything and then possibly made one careless mistake, could be how this has happened. It is definitely not easy. And so if that's your target, focus on speed. Focus on being able to actually do the front part even faster than I did, because I needed to talk a lot. And at the same time, realize that even towards the back side of the paper, the questions difficulties are a bit all over the place. So you should glance at it, and if let's say that you realize that, oh my goodness, I'm looking at the questions and 4 out of the last 5 are geometry. Well, if you are comfortable with geometry, then budget some time for it. If you are not comfortable with geometry, then perhaps just focus more on the front section. Okay, so that is all for this AMC12B. If you haven't yet seen the video for the AMC12A, you may do so. And all the best in case you are seeing this just before the AMCs take place.